Hello students and friends, welcome to my YouTube channel. Today I am going to solve this one support reactions problem. So this given problems is there in your board. Find the support reactions of the given figure. AB is the beam. AB is the beam. One point load is there. One UDL and UVL, uniformly distributing load, and UVL, uniformly varying load, both are connected together. So how we will solve this? So before solving these problems, we will analyze this part. This part we will analyze. So look here. I will draw here separately that one. Is there UDL, uniformly distributing load. These symbols already you know, these symbols will be like this also. This symbol, both are same. This is called rectangular section. Another is triangular. This is called UVL, also known as triangular section. This is called triangular sections. So what we will do here, once we are solving the questions, we will draw the load diagram. All load will convert into point load. All load will convert into point load. So see, this already one point load is there. UDL load also will convert into point load, and UVL load also will convert into point load. How will convert? So already I told UDL is nothing but rectangular section. So load means length into breadth. Suppose this is length, this is breadth, area. Area will be the load. Area will be the load. So what is the here? Area I will find 6 into 10. So 6 into 10 equal to 60 kilonewton. That is called load for the UDL. Then what is the load for the triangle? Area of the triangle, half into 6 into 30. So 90 kilonewton. 90 kilonewton will be the load. Load I know. Then where will act the load? Another point is where will act the load. So UDL means where will act the load? At the middle point. Why? Because rectangle having center of gravity point is middle. Center of gravity point nothing but entire that body weight will act at the particular point. That point is known as center of gravity. So where the load will act? Vertically downward in the middle only. Middle only. So what is this distance? 3 meter, 3 meter. So UDL load will act in middle. Also other concept what is? If will be the deflection. This suppose this is their load 10 kilonewton per meter. Then load will act in the middle. How? If we will go the deflection, the deflections will be in the middle, maximum deflections in the middle only. That means load will act at the middle point at 3 meter. Same UVL, how will act the load? So load now, how will act the load now? What I discuss here? Load will act in the CG point. So we will find the CG point for the triangle, then we can find out. So okay, I'll draw one triangle here again. Suppose this is H, this is B, this is H, this is B. I need the CG point for this triangle. I need the CG point of triangle. So just we can imagine center of gravity point means entire the triangle weight will where will act at the near the base. Near the base. Suppose this is the area, just assume. This is the CG point. This is the CG point. So entire triangle weight will act here. Then how much this distance? That only we have to find out. How much distance? This approximately I know. This is the point for the center of gravity. Now what will be the distance from here? Suppose we are here, what is this distance? Suppose we are here, what is this distance? How to reach here? From here, how to reach this point? From here, how to reach this point? So here, one derivation is there, we are getting that, but now we have to remember only. So this side, if you will travel from this point to this point, if you will go, it will be 2h by 3. If from this point to this point you will come, it will come h by 3. If both you will add 2h by 3 plus h by 3, it will come h only. So final distance h only. Similarly, suppose you are coming from this point to this point, it will come 2b by 3. And from this point to this point, if you are coming, it will come b by 3. So we will reach the center of gravity point. This is the distance b by 3. This is the distance, 2b by 3. From this side to this side, 2h by 3. And from this side to h by 3. So that means from the lower cross sections, 2h by 3. Bigger cross sections, h by 3. This you can remember. Another simple how to remember. Let us assume H is equal to 6. 6 is there, no? So 2 into 6 by 3, it is coming 4. B by 3, that means 6 by 3, it is coming 2. So that means this distance, this total distance, we are dividing into 4 plus 2. So this is the 4, this is the 4, this is the 2. That means from this side if you are measuring, we will write 2h by 3. Because 2h by 3 coming 4, h by 3 coming 2. So 2 distance from here. So from longer distance 2h by 3, shorter distance b by 3. If this concept you know, we can solve this question. So look at now. This all the explanations I given. Now we'll draw the new load diagram. Again we'll draw the load diagram here. Okay, this line I drawn here. Load diagrams I have to draw. Now this is the load diagram. This is the load as usual will act here. This is the load will act here. How much? 8 kilonewton. Will be 8 kilonewton. Now what will be the load here? Okay, just will draw little straight line. What will be the load here? First it will take the UDL. UDL na load will act where? In the 3 meter. So this 3 meter from here, 3 meter load will act. What is load? Area of the triangle. What is area of the triangle? 10 into 6. Area of the rectangle 10 into 6. 60. We can write here 10 into 6 equal to 60 kilonewton. Kilonewton. This is the load. Okay. Now this is the distance 3 meter. Now what is the load? 90 kilonewton. Where that load will act? At the 4 meter. At the 4 meter. This load will act at the 4 meter. 90 kilonewton. How this came 90 kilonewton? 1 by 2 into 6 into 30. Triangle. Triangle, what is area of the triangle? Half B into H. So this is B, this is H, 30. So 9 into 6 into 30. So now we got the load diagram. Once we know the load diagram, that load diagram is all the point load. So very simple way now we can calculate. So this is the support reactions. This is the support reactions now RA. This is the support reactions RB. This distance, total distance how much? 4 plus 2 plus 6. So this distance is 2 meter. This is 4 meter. This is 3 meter. So all the distance I know. So this distance will be 4 meter. This distance will be 2 meter. So how we'll find? So already I told 2 equilibrium equations will apply here. 2 equilibrium equations will apply here. What are the equilibrium equations? Summation of total vertical force equal to 0. Summation of total horizontal force equal to 0. Moment about any point will be 0. So this is called 3 equilibrium equations. Now we'll check this. This given questions is what is statically determinant or statically indeterminate. So this given question is statically determinant only. What is statically determinant? If given reaction forces will be less than the equilibrium equations or equal to the equilibrium equations, this load diagram is known as statically determinant. Indeterminate na, this support reactions will be more than equilibrium equations. Suppose one cantilever beam is there and one load will be here. Some load will acting. So suppose fixed place is there. Here 3 reactions will act. One vertical force, one horizontal force, one moment. Suppose point A na moment out A. Here suppose this is pin or hinge. Suppose pin and hinge na. Suppose this point is B, RB. How much? 1, 2, 3, 4. 4 reactions will be there. Equilibrium equations will be 3. So this is called statically indeterminate beam. So statically indeterminate beam we cannot calculate this way because unknown will be more. But here only 2 reactions, RA and RB. Here 3 equilibrium equations. So we can solve this question. So this given beam is nothing but statically determinate beam. Statically indeterminate beam na number of reactions forces will be more than the equilibrium equations. Okay. Now look here. How we'll solve? Sigma Fv equal to 0. So what will be there here? Total upward force equal to total downward force. What is upward force? Ra plus Rb equal to how much load? How much load? RA plus RB equal to total load how much? 8 plus 60 plus 90. So this will come how much? 158 kilonewton. 158 kilonewton, equations 1. Another equilibrium equations, what will take? Moment about A. So once we convert it into the point load, then it will be very simple. Moment equal to what is? A point is fixed. Due to the A, how will rotate? 8 into 4 length, force into perpendicular distance. So here what will take? Total clockwise is equal to total anti-clockwise. So this is clockwise moment. What is? 8 into 4 clockwise plus 60. What is the distance? 60. 4 plus 2 plus 3. 7 to 9. 9. So total distance is 9. 60 into 9. Another force, this also will rotate in the clockwise direction. Another clockwise directions. 90 into what is total length? Up to this 9. 9 plus this, okay, 4 plus 4, 8 plus 2, 10. 8 kilonewton. 8 into 4, perpendicular distance, 60 into 9, this is called 10. Now remaining force RB, so it is anti-clockwise. RB into total distance is 12. That's all. This if you know, now we can calculate, we can get the answer. So we'll write somewhere here, how much this? This will be 32 plus 590 plus 900 equal to 12 RB. So RB is equal to nothing but 14, how much this? 1488 coming. 1488 divided by 12. So RB is coming 124 kilonewton. Now substitute this RB in equation 1. So you will get RA is equal to 158 minus 124 is equal to 34 kilonewton. 34 kilonewton. So this way we can get the support reactions of RA and RB. Support reactions we got RA and RB. This is the method. So what we observe here, if like these situations will be there, find the load. Load is area of the rectangle. Load is area of the triangle. Where that load will act? That area load we got, where will act, load will act? At the center of gravity point. So rectangle center of gravity will be middle, rectangular, the triangular center of gravity will be 2h by 3 from this side. So this way we can calculate, find the distance, then force into perpendicular distance, will get the moment, and we will calculate the problem this. Okay students, how you feel this? Give the feedback and like the channel and subscribe this. So